On this next problem, we're trying to sketch the graph of f inverse given the graph below. So this graph below is f, and I'm going to do that in red. Okay, so I want to get these points off my picture so that I can find the inverse of them. So let's see, the first point I'll start with is -2, comma, -3. That's this one down here at the bottom. The next one, -1, comma, -1. And the next one on the y-axis looks like 0, comma, +1. And then the next one after that, the last one, is 1, comma, 3, it looks like. Okay, so these are the points for my function f, but I don't want those points, I want the inverse. Now, to get the points for the inverse, all I need to do is take the x values and the y values and interchange them. So instead of -2, comma, -3, I'm going to have -3, comma, -2. Notice that the negatives didn't change at all. If it was negative, it stayed negative, okay? All you're going to do is switch the places. So -1, comma, -1, switch that around and it becomes -1, -1. 0, comma, 1, switch it around and it becomes 1, comma, 0. Again, I'm not changing things from positive to negative, I'm just changing the order. And then 1, comma, 3 becomes 3, comma, 1. So I'm going to go ahead and plot those. So I have -3, comma, -2. -1, -1 happens to be the same point as one of the red points, and that's okay. 1, comma, 0, and then 3, comma, 1. And that is all you have to do. Connect your points, put arrows on it, and that is all you have to do for that problem. Now, if you want to go the extra mile, if you want to think about it, you don't have to. If you kind of think about folding it along this line, the red line and the blue line should cross or meet, should touch if you're reflecting it over the diagonal line y equals x. Now, you don't have to do that. I'm going to go ahead and erase it so I don't confuse anyone. But, you know, just as a checker, it should match up there. Okay, on our next problem, given this function, f of x equals x minus 1 quantity cubed, find the inverse. Okay, so this is a four-step process. Please don't confuse this problem with number 13. Number 13, I gave you two functions, f and g, and I said prove that they're inverses. On number 15, I gave you one function and I said find the other inverse function to this function. You can't use these two processes interchangeably. A lot of times people try to do number 13 using the methods from 15. You can't do that. So make sure that you're doing both of these the way that I told you to, because that's the only appropriate way of doing it. So on number 15, the first step is to take my function f of x and take out the f of x and replace it with y. So we're going to write your steps to the left, but I'm going to do the work right under the problem. Okay, step 2 would be to interchange the x's and the y's. The reason I'm doing that is because I'm taking this function and I'm turning it into an inverse function. It's going to be a totally different function from here on out. It's going to be the inverse, but it doesn't look right. So in step 3, what I want you to do is I want you to solve for your new y. So on this particular problem, I'm going to just rewrite it again just so you don't get confused later. So on this problem, I need to get rid of the -1 and I also need to get rid of the cube. Because the cube is the outermost function that I need to get rid of, what I'm going to do is I'm going to cube root both sides first. Some students want to get rid of the -1 first, but in this case, because the cube is on the outside, we need to cube root it first. This gets me the cube root of x equals just the inside y minus 1. Because the cube and the cube root undo each other, I don't have to put plus or minus because it's not a square root, it's a cube root, so I don't have to do plus or minus at all. The last step is to add 1 to both sides. Notice that when I took the cube root was only over the x on the left-hand side. So therefore, the cube root only goes over the x. The +1 should go after it. Make sure you stop the cube root little tail. Just make sure it's over the x only. Okay, well I've solved for y. Our last step, do it in black, is to take the y and put it back into the function notation, but in this case it's going to be f inverse because it's not the regular function, it's its inverse, so you need to put that little -1 up in, looks like the exponent. It's really not an exponent, it's a notation for inverse. And that is our final answer. Now I'm going to give you a bonus problem here. I have had some students in the past have a kind of a tricky time with this. So just as a bonus, okay, question 15b will say, let's do the same thing but for this problem here. F of x equals x cubed minus 1. Notice how it's almost exactly the same, but I put the cube on a different spot. Okay, I just want to make sure you know how to do this. So step 1 says change f of x into y. Step 2 says interchange the x's and the y's. Notice that the cube didn't change. I just changed the letters there, okay? Just be careful there. Step 3. This is the place where people get confused versus the first problem versus the second problem. So make sure that you're doing this correctly. On the first problem, I had to cube root both sides first because the cube was on the outside. In this case, the outermost function is the -1. So because that's the outermost function on this problem, I need to add 1 to both sides first, which gets me x plus 1 equals y cubed. Now I can cube root both sides, which gets me y equals the cube root of, notice that the x plus 1 was all on the left before I cube rooted it, so the cube root house goes over both the x and the plus 1. My last step is to take the y and change it into f inverse of x. Okay, so notice that it's like almost the same answer, but it's very, very different when the tail goes all the way over the 1 versus when it does not go over the 1. So that's one of the biggest problems people will have, is where to stop the tail on this problem. On the next problem, we have a distance problem. Find the distance between these 2 points. Well, in order to do that, I need to have the distance formula. So the distance formula is going to be d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Make sure you have the minuses inside the parentheses but the plus between them. It's very, very tricky to get. You can get those mixed up real easily. Okay. The other thing I highly suggest is that you label your x1, y1, and x2, y2. So I have d equals the square root of, parentheses, x2. My x2 is -1. But then I have a red minus because there was a minus in the formula. Then x1, which the x1 happens to be 5, parentheses squared, plus y2. Let's see, who's y2? That's 3 minus y1, and y1 happens to be -2. The minus comes in red, comes from the formula. The -2 comes from the negative in the point. Quantity squared. Okay, so make sure that you put everything in the right spot. If you mix them up, you get the problem wrong and you miss a negative, which messes up the whole thing. So be very careful there. So distance equals, okay, inside the parentheses I can add or subtract. -1 minus 5, that's -6. 3 minus a -2, add a line, change a sign, that's really 5. So d equals -6 squared, that's -6 times -6, which is +36. 5 times 5 is 25. And then when I add those two together, I'm getting 61. So distance equals the square root of 61. Technically 61 units because we have a length, but we don't really have a length in this problem. So d equals root 61 should be sufficient. Alright, the last one for this page, it says find the midpoint. Notice I use the same points, but because I'm trying to find the midpoint, I need to use a different formula. So the midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. Again, I highly suggest that you label your x1, y1. Okay, so we have x1, which is 5. Notice in this formula, they're all pluses. So be careful between the two formulas when you're memorizing them. Plus x2, which happens to be negative 1, over 2, because that's what it says in the formula. On the second point, I have y1, which happens to be negative 2, plus, because there's a plus in the formula, y2, which happens to be 3. Okay, so when I add these together, I'm getting 4 over 2 for the x-coordinate and 1 over 2 for the y-coordinate, which gives me, when I reduce, 2, 1/2 as the midpoint.